this is our s. Alright, so from the function s, we need to find the instantaneous velocity v. So we need to do differentiation from the function of s. So after we differentiate the 2t squared, we'll get 4t, negative 3 become negative 3. Sorry, negative 3t become negative 3, and plus 6 after differentiated becomes 0. Therefore, our velocity function only v equals to 4t minus 3. Then we need to find when t equals to 1/4, what is the instantaneous velocity? So sub the 1/4 into the t. So we have v equals to 4 times of 1/4 minus 3, which is 1 minus 3, and we get v equals to negative 2 meter per second. Number 2, when the t equals to 2, what is the instantaneous velocity? Again, we sub the 2 into the function of v. 4 times 2 minus 3, and we get v equals to 5 meter per second. When t equals to 6, v equals to 4 times 6 minus 3, 24 minus 3, and we get 21 meter per second. B, we need to calculate the time in seconds when the instantaneous velocity of the particle is negative 1 meter per second. So this time v is given. We need to find t. So when negative 1 equals to 4t minus 3, then move the negative 3 become positive 3. Negative 1 plus 3, we get 2. So 4t equals to 2, therefore t equals to 1/2. When v equals to 5, number 2. So 5 equals to 4t minus 3, and 4t will equals to 8. So the t equals to 2 seconds. Number 3, when v equals to 9. So 9 equals to 4t minus 3, and the 4t will equals to 12. So 1t equals to 3 seconds. Question number 2. A particle moves along a straight line. In this its displacement s meter from a fixed point O at t is given by s equals to 2t cubed minus 5t squared plus 4t. Find A, the instantaneous velocity in meter per second of the particle when t equals to 2. Again, we are given the function of displacement, and we need to find velocity, where velocity is the rate of change of displacement. So we need to do differentiation. So we differentiate the s, and we get 6t squared minus 10t plus 4. So this is the function of velocity. So we need to find the instantaneous velocity when the t equals to 2. So sub in the 2 to the t. So we get v equals to 6 times 2 squared minus 10 times 2 plus 4, and we get 8 meter per second. B, find the value of t in seconds when the particle stops instantaneously. So the clue is here. When the particle stops instantaneously. So when it stops, it has no velocity. So the velocity equals to 0. So at that instant, v equals to 0. So the function of v, 6t squared minus 10t plus 4 equals to 0. And we can factorize out 2. Become 3t squared minus 5t plus 2. So we do factorization so that we can get our root. So factorize the 3t squared minus 5t plus 2, we get 3t minus 2 and t minus 1. So when 3t minus 2 equals to 0, we get t equals to 2 over 3 seconds. Or when t minus 1 equals to 0, we get t equals to 1. C, the range of values of t in seconds when the particle moves to the right. When the particle moves to the right, this is the key. When it's moving to the right, the velocity is positive. So v greater than 0, and from the function of v, we already factorize. So I straight away bring the function of v here. So we have 2 times 3t minus 2 and t minus 1 greater than 0. Then I will have a quadratic graph with respect to t. Alright. And then we want the function greater than 0. So we want the part that above the t-axis, which is the t from 0 to 2 over 3. You must be curious, why do we start with 0? Because t is about the time, right? So we always start with 0. N must be less than 2 over 3 as in the graph here, or t greater than 1. Number 3. Oops, thank you.